Welcome everyone to today's lecture and the chapter of laws of motion. So in the last video we were covering topics about how to do questions of a block placed on an incline when they are tied to a string, and when a block is connected to multiple strings, how to do those questions. So in this video we are going to move ahead and basically do questions in which the block itself is moving when it is connected to a string. So first we will be starting with the question. So question number 6 we will be starting with, and this is a question in which there is a wedge. Now what is a wedge? Wedge is a triangular prism, we can say. It's a prismatic volume, and we can imagine in this way that it is of this shape actually. So this is what we say if we can imagine in 3 dimensions. So this is how a wedge looks like. But to draw in 2 dimensional, we usually do not draw those surfaces and represent the wedge by simply drawing a triangle. So this is a wedge. It has a smooth slant surface. The angle of inclination of the wedge is alpha, or you can even imagine that the wedge is some incline which is actually able to move. So this is the inclined surface of the wedge which we are talking about, and on top of and on its surface there is a mass m kept on it. Now the question is, the wedge moves horizontally with the uniform acceleration a, such that the block of mass m kept on top of it doesn't slip. So you have to find a in terms of g and alpha. So how do you do it? So first of all, we'll select our system. So we want to study the mass m. So our mass m is the system. So we'll be drawing the figure of mass m only. And next, let us draw what are the forces acting on m. So the forces acting on m would be the gravitational force mg, and one more force. So we know that the common normal force, or the normal force, acts along the common normal direction, along this particular direction. So the common normal force would act along this direction on the block and along this direction on the wedge. And since both are these forces are action reaction pair, as this is exerted by m on the wedge and by wedge on small m, so these are action reaction forces, so they would be equal in magnitude. So one thing which serves very conveniently for us is that even though the whole system is accelerated, the wedge is accelerated, and including that the mass would also have an acceleration a. The masses have an acceleration a because of the fact that it is given that k, mass m is not slipping, does not slip on the wedge, and if it is not slipping on the wedge, that means it has same acceleration as that of wedge. So even if their accelerations, even if the whole system is accelerated, the normal reaction would be acting in this direction only. Additionally speaking, the acceleration does not affect the direction of normal reaction. The direction of normal reaction would remain along this common normal direction. So that complication is never there. So the normal reaction acting on the mass m would be acting in this direction, as we have shown, and this is the direction perpendicular to the incline, and we know that the angle which the gravitational force makes with the common normal is alpha. So the result of these two forces acting on the block is the acceleration a. We know there is no other forces acting on the block, only normal reaction and mg. So the acceleration of the block is towards right. So now we have to decide what are the axes which we are going to choose. So like I advised in the first question, or even in fact before doing any question itself, the advice was that we will be choosing the x-axis and y-axis, or try to choose in such a way that the acceleration of the block is in one direction, and in the other direction there is no acceleration at all. So we try to choose the axis in such a way that in one direction there is some acceleration and in the other direction there is none acceleration. So we chose the acceleration x along the horizontal, and we will be now resolving the forces. So this angle is alpha, and the resolution of alpha along x-axis would be n sine alpha, and the value of n along the y-axis would be n cos alpha. So then we'll be writing the equations. That is a step number 4. So sum of forces along x direction is equal to mass times acceleration. Sum of forces along y direction is equal to mass times acceleration along y direction. So forces along x-axis is some n sine alpha is equal to m into a. Since there is no other force along x direction, only n sine alpha. So n sine alpha is equal to ma, and we know that what is the component of normal reaction along y-axis. So that component would be the component which is closer to the angle alpha, which is n cos alpha. So n cos alpha, that is in positive y direction, and mg, that is in negative y direction, is equal to mass times acceleration in y direction, which is 0, since the block is not moving in y direction at all. So all the acceleration of the block is in x direction. There is no acceleration in y direction. So this gives us n sine alpha, n cos alpha equal to mg. Dividing the equations in blue and red, we get tan alpha is equal to a by g, or g tan alpha is equal to a. This is the acceleration of the block which we have to maintain so that the mass m is not going to slip over it. Okay. So let us start with the next topic. So the next topic is two mass and a pulley system, which is known as the Atwood machine. So in Atwood machine, what we have is you have a pulley, and the pulley is having a string or a rope around it. So this is the rope around it, and there are two blocks which are attached to the pulley, and we have to analyze this particular system. So this is a cross section of a pulley which is drawn here. That is the pulley, and if there is a pulley in front of you and you take a vertical cross section of it along its diameter, then you would see the axle of the pulley and so on. But first we will see what the Atwood system is and how to solve it. So you have a pulley, it is connected to the roof is rigid. This part of the pulley is called the clamp, is usually called the clamp or the hook of the pulley, which is used to balance this whole pulley. This is the pulley itself, and the pulley has grooves inside it, which helps us in putting a rope in it. So we put a rope across the pulley. So this is drawn by dotted line, because this part is inside, is hidden within the pulley, and by a solid line when we are seeing the rope outside the pulley. So the rope is completely present even though we are not able to see it, since it is within the pulley. And then we mark the masses. The masses are m1 and m2. So let us assume the mass m1 is greater than m2, and the action of gravity is mg. So we'll assume that the action of gravity is a constant and that the pulley is fixed and smooth. So at first, what is written here? The tension force due to the rope or the string acts along the string. So this is what we already know. and it acts in upward direction on both the blocks. That is what we already know. We know that if we were to study M1, the tension acting on M1 would be in upward direction, since tension can only act along the string. So that is that is how we'll be drawing the tension in this question. So the first important thing which we must remember in all the pulley block questions, whenever we are given a massless string, when we are given massless string, then the tension across the whole string is same. That means if, let's say, tension in this part of the pulley is T, this part of the string is T, then tension here should also be T. So tension in both the sides of the diagram would be value T, since the string is massless. So this is true even though the string is moving or not. Even if the string is moving or if it is not moving, it does not affect the value of tension. So let us move ahead. We have a mass m1 and we will be taking the gravitational force on mass m1. So first we will be studying m1 mass. So m1 mass, the gravitational force on m1 mass is some m1g, and the tension acting on m1 mass is some upward force, that is tension T. Similarly, let us draw the diagram of mass m2. The gravitational force on mass m2 is downwards and the tension force on the mass m2 is upwards. So here we will be noticing that even though m1 and m2 are not moving in the direction of tension, the tension can only act in the direction of the string, and since the string is upwards, tension would be acting in that direction only. String is tight, it is trying to not elongate itself, and that's why it's essential that the tension acts on the systems connected to it in its own direction. So this is our free body diagram of the masses m1 and m2, and let us say we want to find the acceleration of the system. So how would you find the acceleration of the system? So both the blocks won't be moving with this in the same direction. If m1 is moving down, then m2 would be moving up, and if m1 is moving up, then m2 would be moving down. And yeah, that has to be there. That means there is no certain value. There is no common value of the acceleration vector, because the direction of acceleration vector for both values m1 and m2 would be different. But the magnitude of acceleration of m1 and m2, what would that value be? So we can say that the distance moved by m1 in downward direction would be matched by the distance moved by m2 in upward direction. So we can say that the acceleration of mass m1 should be equal to the magnitude of acceleration of mass m2, since they are going to cover the same distance in t time and their acceleration are going to be same. Again, why the acceleration is going to be same? Because the forces are the same, or not same, but forces are constant. Since the forces are constant, that's why acceleration has to be same. And that's why, since they are going to move with the same displacements in upward and downward direction, then that would mean that the acceleration of the blocks have to be equal and opposite. So let us mark the accelerations of both the blocks. Let us say m1 is having a downward acceleration a, and m2 has an upward acceleration a. So now, after having decided the acceleration and having thought about, okay, what is the direction of tension acting on both the blocks, what is the value of tension, now it just becomes the question of solving some equations. So the main idea is to arrive at the figure and to understand what is happening in the figure. That was the main idea behind discussing the two mass and a pulley system, that how to draw a figure, how to approach a figure, and what is the right way to approach that. So the right way to approach is by drawing the FBDs of both the masses and deciding the direction of acceleration, deciding the value of acceleration, and finding whether there is some relation between the acceleration of the blocks. So like in this case, the acceleration of both the blocks have equal value and they are opposite to each other, because as m1 is moving downwards, m2 is moving upwards. Solving the question would be relatively easy. If we are to draw the equation of mass m1, let us say we are considering the downward direction as positive, then we would say m1g is positive, tension is upwards, and it is opposite to the direction which we have selected, and that is minus t is equal to m1 into the acceleration a. And then let us draw m2. For m2, let us select that downward direction is positive. Let us say the same convention which we have selected for m1. So m2g is in downward direction, it is positive, tension is in upward direction, it is negative, and our acceleration is in upward direction, which is again the opposite of our selected positive direction. That's why it would be negative. So this equation would become T minus m2g equal to m2 into the acceleration of the block. So solving 1 and 2, equation number 1 and 2, if we add these two equations, then the tension would cancel out and we'll get the acceleration of the whole system. So the acceleration of the blocks would be m1 minus m2. Here m1 is having a positive sign, that's why m1 is positive. m2 is having a negative sign, that's why it is negative. m1 minus m2, there would be g common over here, so there would be g, and it would be divided by m1 plus m2. So that would be m1 plus m2. So this gives us the acceleration of both the blocks. And when we substitute the value of acceleration in the equation of tension, then we would get tension equal to some 2 m1 m2 upon m1 plus m2 into g. So this equation we can arrive by substituting the value of acceleration in this equation. So where would we substitute? We will substitute in the value of a, and we'll get this value of tension. So let us move ahead. So like you can see here, we have solved the equations, we arrived at the equations and we have solved it with the value of acceleration. After substituting the value of acceleration in the previous equations, you would get the value of tension in the string. If we revisit the figure of the pulley again and consider the pulley itself as a system. So let us consider the pulley as a system. So this is the pulley, and how to decide in which direction the tension would act. Again, the same concept will be using, same idea will be using. The tension can only act in the direction of the string. So the string is downwards when it is in contact with the pulley. So the tension would be acting in downward direction on both the ends, since the string is existing in both the ends, and there is a clamp which is trying to prevent the pulley from moving downwards. So as is marked in the figure, let's say there is some force exerted by the clamp. So this force exerted by the clamp is on the pulley. We are drawing the figure for the pulley, and this force would be upward in direction. So this would cause some stress in the clamp. So the upward force, what is Fc? The upward force by the clamp on the pulley. So if we consider this pulley and draw and write an equation, so we have already drawn the force body diagram. So we'll write the equation, or we can directly write the equilibrium conditions, that the upward force acting on the pulley should be equal to the downward force acting on it, since there is no acceleration of the pulley itself. And we have already calculated the tension of the string in the previous page. So we would say that the clamp force is some 4 m1 m2 upon m1 plus m2 into g. So let us take an example to demonstrate this. The example is that the value of m1 is 5 kg, m2 is 4.8 kg. We have the same figure as we have been studying, that you have a pulley which is smooth, you have a massless string which is wound, put on top of the pulley, and there is a mass m1, there is a mass m2. The mass m1 is some 5 kg as is given, mass m2 is some 4.8 kg as is given, and the value of g is given as some 9.8 meter per second square. So this is given in this question. So to find the acceleration of the pulley of the masses m1 and m2, you have to find the tension in the string, and you have to find the force exerted by the clamp on the pulley. So we already know the equation for acceleration. So if you are watching at home, then I would encourage that you would derive the whole equation again, just to get some confidence in writing the expression. But since we have already derived the equation just now, we'll be using the expression which we have just derived. So the acceleration of mass is given as m1 minus m2 upon m1 plus m2 into g, and the acceleration is given as m1 minus m2 is some 0.2 divided by m1 plus m2, which is 9.8 into 9.8, that is some 0.2 meter per second square. The value of tension in the string would be some 2 times m1 m2 upon m1 plus m2 into g. So the value of tension would come out to be some 2 times 5 into 4.8 divided by 9.8 into 9.8. So this value would come out to be some 48 newtons. This is the value of tension. And we know that the force exerted by the clamp on the pulley is some 2 times the tension, so that would be some 96 newtons. So let us move to the next part. So in this question again we have an Atwood machine. So we are given masses m1 and m2. Again m1 is greater than m2. But it is given that initially block number 1 is moving upwards and block number 2 is moving downwards, and as this figure is describing, they are moving at the same speed. So the question is asking that then the magnitude of acceleration of each block would be less than m1 minus m2 upon m1 plus m2 into g. Tension in the string would be more than this value. Force exerted by the clamp would be this, or all of the above. So now we have to think a little bit. What we already know is that we know that the acceleration of the block is governed by the forces, but having some velocity definitely clouds our thinking and complicates our thinking. It forces us to think that okay, m1 is going up, but m1 is more than m2. So first of all, this is not a situation which would happen if m1 and m2 were at rest initially. Like in the previous question, we never said that m1 and m2 were at rest initially. We simply jumped on the idea that m1 is more than m2, and what were the forces acting on m1 and m2, what was the direction of tension, and from that we decided that okay, since m1 is more than m2, it is logical to assume that the direction of acceleration of m1 would be downwards. So how come this question is saying that m1 is moving upwards? How is that possible? When we are saying that m1 has a downward acceleration, how come m1 has an upward velocity? So the idea is that, think from the chapter of kinematics. Is it necessary that acceleration and velocity have same direction? The answer is no. The question can give you any initial condition, and by that we mean that there can be any initial conditions present in nature. For example, if a car is moving in forward direction, if we apply brakes in the car, then the acceleration of the car would be negative. Think in that way, that even if the m1 can have an acceleration which depends upon m1 and m2, its velocity or its initial velocity is not in any way influenced by the acceleration. So the question has given that the velocity of m1 is in upward direction, and because of that, to keep the length of the string constant on both the sides, m2 has a velocity in downward direction, but the acceleration of m1 would remain same. Why would it remain same? Just because of the fact that the forces on m1 remain same. Since the forces on m1 and m2 would remain same, their equation would come exactly same as before, and solving those equations would be exactly same as before, and you would get the same value of acceleration. So the magnitude of acceleration of each block won't be less than this value, it would be exactly equal to this value. So this option is wrong. Since the acceleration of both the blocks m1 and m2, we have decided that their acceleration would remain same, the tension of the string should also remain same. So the tension of the string would also be equal to this value rather than more than this value. So this option is also incorrect. One conclusion which we can draw is that if m1 has an acceleration in downward direction and m2 has an acceleration in upward direction, that would mean that m1 as it is going upward it would slow down, and m2 as it going down it would again slow down. So both the blocks, they are going in respective direction, but they would slow down in subsequent motion. Third part is force exerted by clamp on the pulley would be this. So this option would be right, since the tension force is not changing. So that's why the force exerted by the clamp on the pulley would remain this value. So C option would be right. Second question. Find tensions on strings A and B. So let us take the case of part A first. So in the part A, we have masses 5 kg and 4 kg. So again, it's a question, no, not about the question, but what we think is going to happen. So we have 5 kg and 4 kg blocks, and I have not deliberately drawn the string B here. So this is the string A. If the block would release from this position, definitely 5 kg would accelerate downwards, and since it is going to accelerate downwards, it is going to get velocity in downward direction, but that is being prevented by the string B. If I have drawn the string B, it is preventing that motion of 5 kg. That means if I were to somehow cut the string B, 5 kg would definitely start moving downwards, and for that we have already done the whole analysis. What is going to happen now? Now what is going to happen is that 5 kg is being prevented in moving downwards by the string B. So that means that 5 kg won't have any acceleration. So let's say the weight of 5 kg blocks is written as mg. So tension in the string A, let's say that is Ta, should be equal to mg. Mass of the block is some 5 kg and g is 10. So that means tension in string A is 50 newtons. If we were to study block 4 kg, then 4 kg would have a force tension Ta. Now it comes about deciding the direction of tension. String Ta is vertically upward, tension Ta would act in that direction. Tension BTB would act in this direction. And one more force, that is the weight of the block, would also act in vertical downward direction. That would be, let's say, m-g. So if we were to balance these forces, Ta is upwards minus m-g downwards, Tb is downwards, is equal to 0. And this is one way of balancing the equations. So Ta we know, minus m-g, which is 40 newtons, m dash is 4, is equal to Tb, which gives us the value of Tb equal to 10 newtons. So the tension in the string B is 10 and the tension in string A is 50 newtons. Let us do point B. Point B, we have a string in which we have inverted the Atwood machine system, kind of, and there is a pulley, and at the center of the pulley we have balanced a weight by connecting it with a string. This string is named B, this string is named A. This is the 5 kg mass. So we know that tension in string B would be directly 50 newtons, right? That should be easy to guess. Since tension in B is the sole tension which is balancing the weight of 5 kg block, and for the pulley it would be easy to see that tension in right part of the string should be equal to tension in left part of the string, since the string is massless and it should act at both the ends of the pulley, and at the center of the pulley the tension TB would act in downward direction since the string is in this direction. So that means TA should have a value of 25 Newton. It should be half of the value of TB, as there are two TAs here. So let us do one more question. The acceleration of the block of mass m is same in both the cases. True or false? So this is the figure which we are looking for. So this is the mass m in figure number 1. This is the mass m in figure number 2. So the question is saying that in both the figures the acceleration of mass m would be same. So in figure number 1 we are given that there is a mass m, it is connected by a string to mass 2m, and in second figure the mass m is connected to a string which is being applied a force with 2 mg. So what do you think? So again, rather than going by instinct, first let us think that what is the external forces acting on each mass. Rather than going by instinct that okay, there's a mass m, mass 2m, there's a mass m and 2m is replaced by 2 mg, we are thinking about acceleration of the block, right? So first just before jumping on the idea that how we jumping the horse is that okay, the acceleration is going to be same since the figure looks about same only. First thing, that what are the forces acting on m? So the forces acting on m in both the cases would be mg, that would be the weight of the block. But the other force acting which is driving or moving the block m is the tension force. In figure number 1 we know the tension force. This tension force would be some value between m and 2m, and this is what happens when we are taking tension with the formula 2m1 m2 plus m1 plus m2 into g. This is the value of tension. We know this is the value of tension for this system for certain. So this value of tension comes somewhere between m and 2m, and the hint which the question is giving is that here the force exerted on the string itself is 2 mg. So when we have exerted a force on the string, that becomes the tension of the string. So this is what we have to learn here. So what we are learning here is that when we exert a force on a string, then that becomes the tension of the string. So here we are deciding the tension of the string, it is 2 mg. And in the previous case, we know that the tension of the string, it is not going to be 2 mg, it is going to be some value between m and 2m. We can even find that if one mass is m, other mass is 2m, the denominator is some 3m into g, so that value is some 4 mg by 3, definitely between m and 2m and not 2m. So since the tension force acting on mass m is different in these two cases, it is not equal, it is unequal, and the mg force is equal, so by that only we can easily assess that the acceleration of the blocks in the two cases of the mass m in case 1 and 2 are going to be unequal, and we can even say in which case it would be greater. Since tension is greater than this case, it is 2 mg, so it would be more in case number 2 than in case number 1. So our idea that the acceleration of both the blocks is same in both the cases, that statement is false. So that's it for this particular video. In the next video, we will be covering the questions which are remaining in this part of the chapter, that is the pulley block system, which are relatively simple cases. So we'll be covering the uh, questions 4, 5 and 6, and in the video after that we'll be starting with the idea of constraint relations. So thank you for joining and have a nice day.